This is OXDF, and right now I'm looking at wizardcult, the last challenge in the 2021 Flare-On Challenge. I took great notes and got blog posts ready to go for the first 8 of 10. I realized I needed to get moving if I wanted to finish, and so I didn't take good stuff on 9, and now I'm done with 10, and going back and writing it up feels like a lot, so I thought maybe I'd just try something completely new and solve it from the start. I've solved it before, but I don't exactly remember the steps, so we'll kind of do it live here. So with that said, I got a folder here with just the archive. So I'll go ahead and extract that. Needs the password flare, and what do I get is a PCAP. So I'll do Wireshark wizardcult PCAP and take a look. And typically with a CTF PCAP, there's two ways they can do it. They can fill it with junk and other data that you have to actually find the interesting data, or they can just give you the interesting data. And so what I always like to start actually is coming to the conversations tab here. It's like a summary of what's going on. I can step over to your IPv6 and see the different, let's see, we'll jump to TCP and see the different TCP conversations going on. And so right away I can see, okay, all of these are going on port 80, except for this one right here, which is 6667. And for the sake of argument, let's just say I don't know what that is. We can look very quickly. First link, it's IRC, Internet Relay Chat. It's what Slack is actually built on top of. Old school chat platform. Kind of cool that we got that going there. And the rest of this is web. I can also say very quickly, it looks like this .245 is in every one of these. That's probably, it looks like it's the web server. And then 249 looks to be the thing talking to it. Kind of cool. Okay, and then otherwise there's some DNS traffic going on here, and then one 5353 that's actually like to a multicast address. No responses, so that's pretty good. I'm gonna go ahead and say right here, I can say it's probably likely that every packet here is interesting or useful, which makes sense. Flare-On's not known for putting a lot of realistic cruft in here. The goal is to get to the RE pretty quickly, so cool. So now let's close the summary here and come back. And I'll actually start with the UDP just because there's not much of it. I can just sort of rule it out, see if it's interesting real quick. I've got this. This is the 5353 multicast thing I saw. It doesn't make a lot of sense to me. It's worth noting all of this, but frankly, all of these things are not that interesting. There's so much of DNS requests. The one that's probably most interesting here is what I think was my web server making a DNS request for ipapi.com. That is somewhat interesting, and I'll have to keep in mind, what could be causing it to do that. Is the web server getting exploited and then making a request to find out what its IP is or something? I'll keep that in the back of my mind as I go on. Honestly, at the end of the day, this one doesn't. I never actually did figure out where this came from. It's either not relevant or avoided in my shortcut. But so that's really all we need to know about the UDP. The rest of it looks, connectivity checks Ubuntu. It's probably just background processes going on there. So back to the beginning here with the with all the traffic, and the easiest way to do it when you've got eight different streams I saw there is just step through them one by one. All right, so there's a GET request to admin.php. The auth has some sort of, this looks like SQL injection. The name is admin space or 21 equals 1. That's a pretty clear SQL injection, although kind of a weird one. It doesn't, I would expect this to end with a semicolon and a comment or something. This might not actually even work, but anyway, it doesn't matter. And then command equals ID. And then right down here, I have the output in the response, the output of the ID command. So some kind of, I think they're trying to just show some kind of exploitation web shell looking thing here. So the next one, another request to the same thing. The command changes this time. And I can probably just do this in my head, but for the sake of making it a little bit more readable, I'll open up Burp Suite and let's delete those. Start burp. It's probably a million. I could do this on a web page too, but this is easy, and I'll decode as URL, and you can see right here very clearly, it's doing a wget. It's outputting it to /mages tower /induct, and then it's going to wizardcult.flareon.com induct. So it's probably looks to me like it's getting a binary and saving it there, or it's at least getting some kind of file. Let's see, where's our streams? Step up to the next stream. Capture file invalid. That's a new one. Let's try to follow this again and see if we can get it working. Sometimes Wireshark just does that kind of weird timeout, and anyway. Okay, so the next thing we see is the actual GET request. Okay, this is coming, interestingly, if I come down here, this is actually coming from 245, which is the web server, to port 80 on 249, which is the attacker box. So it's now getting induct, the binary. It is interesting we didn't see a DNS request for wizardcult.flareon.com. I bet you that they just put it in the host file to make it easier, but again, in a real environment, you probably would have seen that. Anyway, so then we have in the response what looks to be an ELF binary. That's a Linux binary, so that's pretty cool. Stepping through to the next one, we have another command here, and I won't take this one over to decoder, but you can see change mod plus X on the thing. So it's making the binary executable. What's the next one? Now it's just running /magestower/induct, and on running that, now we see all of the IRC traffic, and this is cool. I'll come back to this and look at this in a little bit more detail in a second, but clearly IRC traffic. After the IRC traffic, there is that request to ipapi.com. This is coming from 245, and it looks like they've blanked out the actual information there, so nothing terribly useful. And then there's some connectivity check from Ubuntu, probably just the background OS. So with that said, there's two things I wanted to look at a little more deeply. First of all, I want to get that IRC traffic. So let's go here, and I want to save that off, look at it more in depth. Here it's stream 5. So what's kind of cool is, so the malware is joining, and then here's the server, which is like on the C2. The malware joins the channel dungeon, and then, it says, a private message to that channel. Hello, I'm so-and-so, level 5 sorcerer. I come from the land of blah, blah, blah. Now we have this account, Dungeon Master, in nice leet speak, replies, what is your quest? And the malware gives the request, and it says, welcome to the party. And then here it goes, you've learned to create the potion of acid resistance. To brew it, you must combine magnifying glass, kernel of grain, silver spoon, fishtail, undead eyeball, coal, ash, silver rod, blah, blah, blah. And it goes on. There's a lot of these, right? And they repeat, and they're moving around. And so immediately I'm thinking, this is some way that it's encoding information. Each of these pieces of things you need, items, represents some binary data that the malware can turn into bits and get commands out of. So now we have a private message back from the malware saying, I've learned how to brew this thing. Sounds to me kind of just like an ACK. Yep, gotcha. Okay. And then it says you enter the dungeon of Graf's Infernal Disco. It's frightening, virtual, Danish, flimsy, blah, blah, blah. Here's virtual again. This is another list of descriptions. It's probably another way it's sending more information encoded into this language. I draw my sword and I walk in. You see a goblin. Okay, I craft my potion and attack. I cast move. Again, now I got another line here. And here on each of these, there's a spell and there's some damage. Looks like a number, D, a number. So again, I'm guessing that there's some information encoded in these I cast lines. And then when it says, I do believe I've slain the goblin, it's probably saying, okay, that's the end of my message. And then Dungeon Master comes back again, and it's starting a new potion. And so this is the cycle again. Okay, now Dungeon Master's coming back. I got more tasking to give you, and this time it's in the form, a new list of things. And after the tasking, there's another dungeon with some more descriptions, and then here we go more. And this time there is a lot of I cast blank for blank damage. It takes apparently a lot of damage to slay the Wyvern. Which means, so maybe this is exfilling a file or something larger, and then it ends. And so that's the end. I'm definitely going to want to save this because I will want to. My theory right now, having seen nothing else about the binary, is that the flag is almost certainly in this information coming back about the Wyvern. It's probably encoding a file in some way and exfilling it through what looks like a dungeon IRC game. And that file is probably going to have the flag. So what I need to do is go reverse the binary, understand how it's encoding that data, and then use that to pull the data out of this IRC chat. So I'm going to go ahead and save this. Save it as IRC.text. And I've got a copy of that now. The other thing I need to extract here from the PCAP is the binary itself. So The easiest way to do that is to come down here and do export objects, HTTP. And now I've got a list here of the different objects passed over HTTP sessions. And right here is induct. I don't know why it jumps over like that when I click, but here it's downloading induct, and I can just click save on that one and save it there. And I can go ahead and close this. In fact, I can, I'm basically done with the PCAP for now. Go ahead and background this and look at what I got now. So if I do a less on IRC.text, I've got the text there, that's good. And if I do a file on induct, all right, so I have a 64-bit executable. It's dynamically linked, great, that's fine. Okay, Go build ID, so it's actually, this is a Go binary. It's not surprising for the 10th challenge on Flare-On. It's gonna be very hard. Go is really difficult to reverse, at least in my opinion. Lucky for me, it's not stripped. And basically that means I'm going to get function names and things like that, which in Go is super useful to have. Things like Ghidra are not the best at putting together how Go handled things, because it does things like calling conventions and returns and things like that. Even strings and variables very differently than you're used to with a typical C++ program. And so it's already going to be kind of awkward in something like Ghidra. But at least having it not stripped means I get the function names and things, which is going to be really useful. You'll see as we go along. I actually was able to solve this without actually having to get really super in depth into how Go is doing things, but more looking at the different functions and how they were called. So before I dive into the binary itself, unless you've done a lot of Go binaries before, they can also be kind of jarring and unexpected. So I'm going to make just like a toy example here to play with to see if we can, see what a basic thing looks like. So let's just call it test.go. And so first I need to make a package here. Main, I'm going to import fmt, which is the package that will allow us to print something. And then we'll just do func main. And inside this function, we're going to call and get add stuff. It's a good thing, 1, 2. And we will fmt.println. Nice simple main there. And so we got to define add stuff. I think probably in Go I'm supposed to be doing add stuff in camel case, but again, this is just a silly little program. Interestingly, in Go, you put the types after the variables. So right here, I'm putting int to say these x and y's are int, and then this int means I'm returning an int for the function. Why this is backwards to everything I've ever done before, I can't say, but that's what we're going to do. Return z. There, and I got a nice little simple program. I'm going to add 1 and 2 together, and I'm going to print the result. So we will write that. We will come down here, and we will do go build. Now, typically you do go build and then test.go. I am going to add a flag here to cheat a little bit. Right now, the Go compiler is smart enough that if I just go build this, it's actually going to get rid of the add stuff function and just inline that into main, because it's only called once. It does the simple thing, so it's not even going to create the function. I want to look at functions, so I'm going to add these flags that allow me to tell it don't optimize for that. So there we go. We'll move up here. So now we can do GDB. Well, first I guess I can just show that produced. Oh, I never moved into my folder. Oh well. Let's do that now. Move test into Go example. It's move test into Go example, cd Go example, vim test.go. All right, and we're back. Test, and we did go into Go example, and we have test, and it runs and it prints 3, just like we expected. So that's great. If we open that in GDB, we can do a disassemble. Now, in Go, it's going to be named. The functions are all named package.function name. So in this case, main.main was our one. Let's see, what did I do wrong? Info functions. Let's see what we got here. And Go brings, everything is just, everything is brought along with it. So you don't, your binaries are often huge and have lots of stuff packaged along with it. Let's see, info functions, void main add stuff is there, and void main is there. Did I do something wrong? Let's go back to the bottom here. Disassemble main.main. Okay, no idea why it didn't work the first time, but let's go up here. So it's interesting here. We could, part of the reason I wanted to just show this is we got the call to main.add stuff. You can see right above that, 1 and 2 are put onto the stack. So it's in RSP and RSP plus 8. Worth noting there. So we're not using, calling conventions is something that there's different calling conventions across different kinds of compiled binaries. This is an example of we are using the stack to pass in stuff. What's interesting is immediately after this, it takes RSP plus 10 and puts it into RAX and then stores RAX into RSP plus 30. So it looks to me, typically in like a C program, you see the return value is almost always in EAX or RAX. And so you see RAX moving into something. Here it looks like we're doing returning via the stack. So if also I can come down here and if I can also do this assemble, say main.add stuff. And so you come in here, it's adjusting the stack a little bit. And then it is right here picking up RSP plus 18 and then adding RSP plus 20. And then it's putting it back on the stack for return, just like we saw. Clearly in the call, there's some sort of adjusting of the stack going on, but that's what I really wanted to show here is it's important to know that both arguments going into functions and parameters returns coming out of functions are done on the stack. And Ghidra is not going to nail that right. So we're going to be doing kind of some looking at it ourselves. One other thing that's kind of interesting to see, let's go up here. Where is add stuff? We'll look at, oh, that's what I'll show. After add stuff, all I do left is print, and and that happens down here. And all this junk gets put in here between, there's this call to conversion. I think that's converting the int to a string. There's all these checks to make sure it worked right. You're going to see this kind of stuff happen, and it's just something you got to get used to. There's also, I'm trying to see if I can find it, and it didn't actually show up in this one. There's another interesting thing that Go does, and maybe I might have taken it out with the compiler options, but it's typical to see at the start of any function, you're going to see it check for enough stack space, and if there's not, it's going to then add stack space and then recall itself. And so just, again, we'll keep an eye out for that. It's another weirdness of Go. So I think that's all I need to show for this example here. I can get out of here and clean this up a little bit. Go back to there, clear our screen. So now we're moving on to the actual binary here, and we're going to open up Ghidra for reverse engineering. And I like to just, let's see, oops, close that. I like to create a Ghidra folder in my working folder to put the project in. So I need a new project. In fact, it's wizardcult Ghidra, that looks good. And we'll call it wizardcult and finish. And then into the project, we need to import our binary. There's induct. So we'll do that, and it's going to be imported. All right, that all looks fine. And then we will drag it up to the code browser to open it up in the code browser. And the first thing it's going to do is it's going to ask us about if we want to analyze it. And so we're going to say yes, and we'll hit analyze. Now there's actually some options in there. Typically when I open a binary, I just take the default. That's what they recommend for the vast majority of binaries. There's actually something in there you can tweak a little bit that will improve the readability of Go. But I figured I'd be better off showing what it looks like before and after, and I'll show you how you can go back and apply some different analyzations. I don't know if that's the right word, analyzers, after the fact. So let's see, is it moving along? Okay, it's moving along pretty quickly here. I don't think I need to pause the video. You can see over here, functions are starting to come. One of the things, even for a tiny binary, if we go back into, let's see, ls-l, was it Go example? Even our tiny little binary here was 1.9 megs. It was all, Go binaries bring along all the libraries they need, and they produce these huge binaries with tons of functions. So that's definitely, like, it's not crazy to see all these functions. Again, maybe you're like, oh, I don't see that many functions, but each of these is just a letter. So like if I go into M, I have these functions plus the ones that start with MA, and look, here's all the ones that start with main. I mean, there's just these are going to be nested. There's a ton of stuff in here to take a look at. This is where it's really nice for us that it's not stripped, because now I can come in here, and in fact, it's still doing the analyzing. I'm gonna let it finish before I start clicking on things, but I've got these main functions, and now it's the 10th challenge, the last challenge in Flare-On. I'm expecting this could be really hard. So I wouldn't put them, it's certainly possible that they are putting stuff outside of main into other packages and things like that. I might need to do some exploring there, but it's a really good place to start when you have a main.main, and here I have a main.init. Those seem like good things to go. Down here, my status bar is done, so I'm done, the analyzing is done. So like I said, I'm gonna click on main.main. I'm a sucker for the decompilation. I used to do this before I had Ghidra. I used to be doing this all in the disassembly over here. But the decompilation from Ghidra for most things is pretty good. So that's generally where I tend to start. I say it's pretty good, and then I come over here, and with Go, it's kind of eh. One of the things you'll notice right away, there's a few things that jump out at me. One, you get these function calls here, like this GitHub LR Stanley, blah, blah, blah. There's another one up here. It's cool the way Go keeps the entire package name in the function call, and that makes it very readable. And in fact, I can say this is almost certainly a real project out in the world. If we come here and check out what LR Stanley has here, there's going to be a GIRC project. And look at that, it is a, it's a Go IRC library, just what I expect. Again, it's the 10th Flare challenge, so it's possible that they mess with this a little bit, but a good starting assumption is going to be that probably these functions that are called here are going to be just like what's on GitHub. So if I want to go look at what's happening there, or just assume that the names of what's happening, new, register, internal, connect, those are probably the things that are actually happening, because people in the real world tend to name their things correctly. I'll also notice right away there's no arguments being passed to any functions at all. They're all just empty, and that doesn't seem right. Random here, even math.random seed, usually you're seeding it with something. Math.rand int n, it's got to have arguments, right? This is where we come up to the analysis and open up the auto analysis. It's this one right here, decompiler parameter ID. If I apply this one right now and analyze, it's going to run through the functions again, and the decompilation is going to get a lot better. See right here, it's doing the analyzing functions down here. I'm going to have to wait for this to finish to show you what's going on. So while it does that, the other thing I did want to show you is up at the top, and you're going to see this in almost every function in Go. There's this check right here where it's checking FS offset. It's getting something out of the FS registers, and it's going back. This actually ends up being like +8. And it's doing this check, and then if it fails the check, it's going to runtime more stack, no context, and it's going to call main.main again, and it's going to return. And so basically what it's doing is Go has this thing where it requires a certain amount of space on the stack, and if that amount of space is not there, then it's going to do that check. If it's not there, it's going to call its own runtime to say, give me more space on the stack, make me some more space to work with, and then it's going to call the function again with the same arguments, and then it returns here because it's doesn't need to, otherwise it would run itself twice. And you'll see this literally in every function. So you can basically just ignore this part when you see it. Okay, we're about done. You can see the progress bar down here in the bottom is now finished, and in real time we got to see it changing. It's not perfect now, but now I definitely have parameters going into these functions, and in a way that it's still not totally intuitive exactly how it lines up, but you can start to at least see the parameters that are going in. So that's quite useful. Cool. So looking at main, let's see. I can ignore. I've already talked about how I can ignore this part. It calls a time.now and gets a time. It then is passing. So, and then again, because we looked at this earlier in our example, it's passing things back via the stack. I think there's probably a way I can come in here and edit function signature and change the return value. Let's see if I haven't tried this before. We set this to unknown, use custom storage. Can I change this? So I could change this to, what is it? Is it probably not size 1. Let's remove that and add in our, it's not going to be a register, it's going to be a stack, and we're going to call it -8. Does that work? Size 8. Well, no idea if this is going to work. Let's see, remove that and click OK. Yeah, I don't know. I suspect there's a way to go in there and mess with things so that it works. When I solved this challenge, I just got really used to, like, it's not as nice as I would like it to be. The OCD part of me wants this have some sort of like var. One of my vars, probably local 140 is equal to time.now rather than this stuff that's going on here. But again, right now I'm trying to just get a feel for what the program's doing. So it's calling time.now to get the time. Then shortly after that, it's calling rand seed. This is a really common pattern to see a random number seeded with the time. It's getting an integer here. There's some. Now this is interesting because it's getting an integer here, and it's also looking at this table, wizardcult table names. But double click on this, it's not immediately clear what's going on here. Although I'm expecting some kind of table. And if I look at the top here, the first word, the first 8 bytes seems to be an address. So 948DC0 fits right into the kind of addresses I'm seeing here. The second word, looks probably like a length, because I've got, so here's my first word runs through 0 through 7. Second word here is going to run F through 8 ending, and this is going to just be OX28. Followed by this is going to be another word of OX28, and then a null, and then down here I've got another address. Let's see, 94. This one's 80. What was this one? 948D. So they are different. Let's see. Let's look at that address. We can come back. If I hit the G key for go, I can do 948D C0. And what do I have here? It looks like another address, followed by another length. So this is interesting. Let's see what's at this address. 74D448. Oh, cool. Okay, that looks like a name, Adamum. And then here's another one, Adlam, Alamar. Okay. And what do I have here? This was this pointer followed by a length of 5, followed by the next pointer, followed by a length of 7. Followed by another pointer. So I'm wondering if these are, that is the address. So I think what I'm saying here is this right here is this global holds this offset here, this address. When I go to that address, I have the table that looks like pointer to a string followed by the length of that string. And so what's cool here is this is actually getting, when I'm getting a random int, it's getting 8 bytes into that, which we thought, we looked above, and that was this 28, hex 28. So I feel pretty confident. I bet you that table has 28 names, or let's see, hex 28, which would be 30 to 40 names in it. And this is getting a random integer between 0 and 39 to get an offset into that. And so then we check. In fact, I bet you the return is this uvar2. Again, it doesn't quite come through. I'm making some guesses here, but so it's making sure that's true and panicking if it's outside the realm. And then it is getting the table name plus 8 plus uvar2 times 10. So it's getting the length of this will be the length of the name. Oh, in fact, main.main, and again, in Go, it's very common to have a pointer to a string followed by the length of the string. They don't null terminate the strings. So it's setting the length of my name to the length of a name, the random name it picked. Is my name show up here elsewhere? Probably. It's probably going to set it somewhere as well. So it's cool. We've saved off my name. Again, we can make a good guess there. I can always come back in detail if it's not working the way I'm hoping, but it does create this IRC connection. There's this other function here which I should take a look at. It then is calling this register function, and the register function is called twice, and it's passed in as an argument main.func1 and main.func2. So if I go into here, do I have any information about what the register function is? Not really. But again, just thinking about how IRC works on IRC, I'm guessing these are going to be handlers for how what the client should do under certain circumstances. In fact, you can see right here, it's making references to a GIRC.handler and GIRC.handler function. So that looks like certain circumstances of things that are going to run. So I'm going to want to definitely look into func1 and func2. And then it does a connect. And oh, then we're in a while connect. Just do a connect, and then it's going to sleep. Presumably these handlers, when things happen on the connect, they're going to be jumping into action. So this is just basically a loop that says as long as you can keep connecting, connect, then sleep for some amount of time. I could probably put a breakpoint in the In fact, we'll do it here. Let's go in to see what exactly that looks like. So GDB, and then I'll do induct. And let's see, I've got my address here. So this is from time.sleep is at 6C188A. So break star X 6C188A. And actually, while I'm at it, I'm going to go ahead and break on this call to connect as well, so I can pick out what's going on there. That is happening right. Let's register internal connect right here. So that's going to be same as above, but C6. So I'll put those two breakpoints in there, and I'll go ahead and run it. So I get a permission denied. That's okay. That's minorly annoying, but I got to just remember to change mod plus X induct. I think that should work. Let's see if I can run it if I have to reload. Yep, okay, that worked. Cool. And so here I am, I'm breaking at the call to internal connect. I can see right here at the top of the stack, there is a wizardcult.flareon.com string. That's useful and interesting to be aware of. I'm probably going to need to add that to my Etsy host file to have this thing resolve. And nothing else. This priv message is interesting as well. I'll have to look for that as I keep going. It's not clear to me if that's being passed into this function or not. So if I continue, it might be hanging right now looking for that. In fact, let's see if I come up here and do a capture on. Oh, I'm not running as real. Let's close out of this and go ahead and reopen Wireshark running as root. We'll do any just for the sake of figuring out if we can find this really quickly. Let's go ahead and get out of that and run it again, and then look for yes. Okay, we ran to this breakpoint. We continue, and yep. So it's making the DNS queries for this, and I'm getting failures here. So it's probably hanging there, struggling with what to do. Let's go ahead and open up a new pane here. We can echo 127.00.1 wizardcult.flareon.com, and we'll add that to Etsy hosts. Might need to do this as root. Actually, I believe I have my Etsy host set so it's writable because I'm lazy. So that actually worked. That line might not work for you. You might have to actually open up your file and add it. But move up here, zoom out of that. We will run again. Let's make sure, let's keep that recording going here for looking for DNS. Don't need to save. And now we're back in here. We will run again. It's breaking at the connect. This time when we hit it, we don't see DNS requests, which is a good sign, because when it reads from Etsy hosts, it's not even going to ever issue a DNS request. But we're still hanging here, presumably because it's trying to do a connection to, in fact, another thing, I hadn't planned on this, but we can do, let's see what happens if we listen on 6667. I don't know if it's still trying. Let's run it again. Step over this, and there it is. It is doing the connection, its connection there. So if we want to debug past this, actually, we're probably going to need to stand up an IRC server. So I'm going to come back to that. We're definitely going to get to that later. I'm going to go back to, we can remember if we want to look for the amount of time it's sleeping, that's basically going to be like a beacon interval for this malware. It's not super important to us right now, but we've already started to figure, we are figuring out we've got this connection to wizardcult.flareon.com, and that looks pretty good. let's go ahead and close Wireshark here for now. And let's see. We'll go back to our code browser window here. So in summary, we have this main.main. I'm wondering if I should even dive into this function. We'll look at it in a second. We've got the main.main. It's creating an IRC client. It's registering two kind of callback functions. It is then trying to connect to wizardcult.flareon.com, and in an infinite loop where it's going to try to connect and then sleep. So that fits into everything we thought we knew from the PCAP. We're going to look into these func1 and func2. Let's go ahead and do that now. Func1 is right here. Oh, let's just come here and click on func1. So same kind of thing. Here's our header that's looking for the stack, making sure that fits okay. There's some IRC commands.join. Don't quite know what's going on there. Fast string, new object. What's going on here? There's some sort of string object here. One thing that's kind of cool here, we get this example of like, here's pvar10 and pvar10.1. That looks very similar with like a pointer to an address and a length. If I open this up here, one of the ways I like to make this show nicely is if this is the string and this is the length, if you come over into this top byte here, select data, choose data type, and then you can put it as char, and I know it's OX17 because that's the length that shows here. Then all of a sudden this shows up like a string. So now it's the potion of watchful rest. Similarly, I can come to this one. Somehow this is already getting made as a string. If I kind of come in here, I can do the same thing. Probably, let's see. This is 7 and the one after it is 1e. So I'll do char OX1e. And it didn't quite work with that one. It definitely, I might need to do it a second time. Char OX1. I think there was some overlapping, strings in there. And so by trying to change it, it kind of confused it, but it worked now. Same thing with this one. And you don't have to do this for all of them, but frankly, I will say when I'm doing reverse engineering, a lot of times what I'm doing is just coming in and labeling variables and making things more readable. And the more you do that, all of a sudden things start to come into picture as to what exactly is happening. So in fact, you can see the potion of watchful rest is being passed into this map assign fast string. So let's see, there's a command, potion.command potion. That's kind of interesting. I might do a couple more of these strings just to try to see if we can figure out what's going on here. Data, choose data type. This is char OX19. The acid's a potion of acid resistance. Now that's one we've seen before. That was actually what was in the PCAP. See, this one is, what is it, 1C? The beast smells quite foul. And this one looks like it's use data type, and this would be char. What do we have here? 15. Infernal Disco, I believe we saw that one as well. So this is starting to look like, I'm not quite sure what this one up here was, but it's in an if else. So I'm wondering if we end up not even using that one and using this one here. And eventually it builds up all this stuff, and then it does a send. What might be kind of interesting to look at here, rather than trying to exactly figure out what all this looks like, is we come in here to our GDB, and oh, we don't have a client set. Well, let's see. We could think. So perhaps now is the time to go ahead and set up an IRC client that we can debug on. So I'll come here, open up a new terminal, and yeah, let's talk about installing an IRC client. And really, when I say an IRC client, I mean an IRC server and a client. We're going to need both of those to make this work. We've got our malware that connects to the server, and then we're going to want to join the server as well. So start with the server. We saw in the PCAP, let's see how I can view IRC.text. We saw here that it is running InspIRCd, how do you say it? InspIRC 2.0. So that seems like a good server to do. So we should be able to do a sudo apt install InspIRCd. There we go. Okay, I got that. And I've done an app update recently, so you should always do that before you do an install. But all right, that seems like it's working. And in fact, let's see, we can probably do sudo service InspIRCd status. Let's see if it's running. By default, it is running. Are we listening on? Cool, and we're listening only on localhost, probably a good place for the default, and we're there. We will work with there's a I like a IRC client called HexChat. If you can find basically whatever you like, but when you open it up, it'll look like this. So we are going. It's got all these default networks. I'm not going to use any of those. We're going to add one. We're going to call it wizardcult, and then we'll edit it. Let's see. It's kind of a weird thing to join. But we'll just do 127.0.0.1. It's the server. Oops, why didn't that work? 127.0.0.1. Maybe hit enter. Okay, that worked. That all works. And for Nick, and we will close that there. Still named new network. Name it. Let's try again. Wizard Cult. Enter. Sweet. And we'll try to connect here, and we'll just connect as OXDF. Is fine. Looking up connecting, looking at my host name. I would like to join a channel. We'll call the channel Dungeon because that's where the bot's going to join. And I'm now talking to Dungeon. That's pretty cool. So with this here, let's see. Now can I run the malware and see if it also joins this same channel? So we'll run induct and see what happens. Takes a few seconds for it to join, but there it is. So we have our random named user is joined, and it introduces itself. And again, if I go to the IRC, the script that I see, and what I saw in Func1, it's going to join and announce itself. And then I believe we saw it's waiting for, the dungeon master to say, what is your quest? So let's give this a try. We're going to change, let's grab this name. Let's see if we can, we'll be the dungeon master. We'll change our nickname to that. And then it's probably too late for this one, but let's go ahead and we need the username and then what is your quest. So we'll copy this here. Let's go back to this window, kill this, rejoin. Let's see if we can get this bot to talk to us. Okay, Usarius has joined. We'll copy that, paste it in there. And boom, as soon as I say, what is your quest? It comes back and says to retrieve the big pterodactyl fossil. Cool. Do I remember what we say next? We say, welcome to the party. Cool. Let's keep talking to this bot. We're not going to do this manually for much longer because it's, as you can see, kind of a pain in the butt to keep doing this. And now the next step would be to send our potion requirements. And again, now that's not something I'm going to manually be typing in. I guess I could type in a short potion, and let's just say through here at the beginning, I need the username. And here, I believe at the end, there's an and there's a dot. Cool, and now it says, so I'm jumping ahead a little bit, but so basically what we've got so far is we can now take this program. So before, we were looking over here and we saw where it was building this initial beacon and eventually sends this beacon. We can now start to debug what's going on. And that puts us in a much better position to dynamically figure out what's going on with the program. So let's come back here and where was my, what window did I have this going? Okay. So now, what were the things I wanted to look at? There was this instance here where we were looking at this send call. We weren't going to reach it because we couldn't connect to a server, so we needed a server. So let's come in here, copy this address, GDB induct, break, put the address in, and run. And now we should have, so our previous bot has left. We're waiting for our threads to spin up, and it has now joined, and it's breaking at that call. Let's make this bigger because we need to see what's going on. And here's the call to send. It's sending the hello, I'm Rentron, level 5 sorcerer from the land of blah, blah, blah. And that seems to be, if I continue through, if I, continue out of here, do a return. I cannot force return. Interesting. Okay, well, let's just continue. I see that posted here, and then we are basically, if we break here, look at our backtrace, we are because it's a thread handling it, we're not going to see it. But I think we're basically out of the first. We're basically, because this return comes right after. So basically, main func 1 is done. That's the end of main func 1. So with that, we can go and look at main func 2. Oh, I remember the other thing we thought about looking at, and that was, I mean, this is kind of a silly exercise at this point, but we did have this time sleep that we're never going to look at because this connect was never going to succeed. So just real quickly, if we wanted to look at what the length of that sleep was, we could do that as well. This happens on this address right here. Copy that. Let's go ahead and set a break, *ox, paste that in. We will run again. It's interesting. I wonder which one we can hit first. I guess we'll probably hit. I don't know which one. We'll see which breakpoint we hit first. Here we are at the send. We'll go ahead and continue. Oh, you know what? I wonder if we're still getting caught in handler 2 before the sleep ever comes. Yeah, okay, that was an interesting experiment. Not important though. We'll bail out on that. So we've now basically covered, just recapping here, we got main.main, which registers these 2 callback functions. It's clear that func 1 is happening on initial connection, and then there's func 2 that we haven't looked at yet. So let's do that now. Main func 2, yep, okay, so here we go. I'm going to do the same kind of thing here where I don't need to necessarily understand exactly what's going on in detail, but up here at the top, I've got my stack check and expansion. There's this interesting is from channel. Yeah, so it's checking to see what channel it's from. None of these are, I can feel pretty confident it's going to be dungeon because that's what we see all the activity happening in. In fact, that might be a DUE. I believe that is a dungeon. That is dungeon right there. I guess we can check this real quick by taking this. What's the fastest way to do this? We'll just go to a silly online thing. If we do hex to ASCII, hex to ASCII string converter. Let's give that a try. There's a hexadecimal value. Paste in. It's probably gonna be backwards because of the byte ordering, but let's just see if we can get an ASCII string out of this. DUNG30NM. I'm not sure where that M comes from. Maybe that other one doesn't have the M, or maybe there's supposed to be an M in the channel. Oh, Dungeon Master. Okay, so it's checking to see if it's from Dungeon Master. And I bet you this one is similar. Let's see. Copy and paste this one in. Did anything change? No, it's the same. So cool. Okay, so we're looking for Dungeon Master. Otherwise, we return. We don't care about messages from other people. Scrolling down here a little bit, some runtime kind of stuff that I can probably ignore. There's some string joining, and then there's this wizardcult comms.ProcessDMMessage. I'm definitely going to want to look at that. Coming down some more, it's looking for an index in a string, an index in a string. Anything interesting going on here? It calls this process message again. So it's interesting. It's now over the course of func 2, it's going to process the DM message twice, and then it closes the client. So once it's done with that, it says, I'm done with this. I'm moving on. Let's dive into process message. There's a lot of variables here. Same kind of thing. There's a string index call. We could break on this and see what it looks like. What I'm going to do at some point here pretty soon probably is go ahead and write a really dummy Python program that can join the IRC and send the Dungeon Master messages, and that'll allow me to break and see what's going on at different points. There's some parsing here. There is a send. So again, we could break here and look at this if we can get to that point in debugging. There's some more looking for index of strings. Oh, this would be, I'm skipping through it, but I should look. This is another case where I've got a string, an address here, followed by, it's labeling it as like a global variable of 15, but 15 is not really a global variable. That's probably just OX15. If I come here, this looks to be very, this looks, oh, look, it's exactly OX15 long. It says welcome to the party. So this is where I can do my trick again to char OX15. Now this says welcome to the party. So this is cool because what I see here is, so let's go back up here to the top. This first one might be worth looking at. And the length is also 15. So data, character type, char, OX15. This first one is what is your quest. So it's looking to see what the index of what is your quest is. And then it's looking for some result on the stack, which probably is the result of the index. And if it's greater than -1, which means it's been found, it's in this message, it's going to do this other stuff. And if not, it's going to continue out here. And what's also, this is a little bit confusing to see, but it does then a check for welcome to the party, which is, so it sends what is your quest, and then if then it processes again and it gets welcome to the party, it's going to just exit right then because it doesn't need to be. That's the end of this. So basically, if that's how it handles the initial joining thing, and that's what this return is right here with param10. Then if we're not doing a welcome to the party message, we're coming down here and we're doing more checks. So we can go ahead and, this one's 23, and I realize it's not like the most thrilling video to watch me sitting here just sort of resizing string variables, but it's so critical to understanding. So what's going on here. You have learned to create the so if that's the message coming from the server you've learned to create, it's going to check and see if it's getting this variable from that result. It's checking if that is less than 0, which would indicate that it's not in the string. So if that string is not in there, it's going to continue and do another check. If that string is in there, we can double click on this and go down. And here is the else, and there's a bunch of processing that goes on here. And so what I really have is a loop. I'm going to go back up to the top, but I've got this loop set up, or I guess it's not a loop, this switch statement in effect, where it's checking to see if you have learned to create is in the message. If it's not, it's going to do another check. If it is, it's going to go do that stuff to process it. So let's see, what's the next check? We can go ahead and keep redefining bytes here. OX, which one? How long is this one? 1C. This is when it stares at you imposingly. It's when you start to see the monster or whatever that you have to fight. This one's 15. Data, change data type. You enter the dungeon is the next one that comes up. If that's there, if that one's not in there, it just if you enter the dungeons there, it just returns. Let's see what we got here. My data, use data type, char, and how long is it? Oh, how long is this one? C. This is just the dungeon. Okay, so so that's why it gets rid of you enter the dungeon because that one's not relevant. But then there's the dungeon string. Let's see, here's another one that's only 1 long. So I guess we'll just set this one to being a char. And it's looking for the dot character. It was interesting. You noticed earlier when I was joining the chat and was manually interacting with it, it didn't sort of say, okay, I'm done receiving this message until it got the period, which said, oh, now I'm actually done. So I bet you, again, I could debug this, or I could really dive into the assembly to figure it out, but I bet you it's building up that potion message, or you enter the dungeon of the description message until it gets to this period character. Another one down here. This one, let's see. Can we clear the data? Might have to set this one twice because we see it's set up as a string already. Do char 6. And it just sort of broke it out. Let's come back here and try again. Data. I'm not sure why when it's already set as a string we have to do this twice, but oh, and now it's displaying it the long way again. Ghidra's weird sometimes, but over here you can see it's showing it just as it is space. And again, right now I'm just looking at this very quickly. But what I've established is, I can go back up now because I've kind of come through the main switching of this thing. It's got different processing routines for you have learned how to create, it stares at you imposingly, and the dungeon, but not you enter the dungeon. And for each of those, it's got a long kind of, what does it do to process what's going on? And so that's really useful. We'll go ahead and I guess start from the beginning, which happens to be at the end of this, the last section here. I guess we'll come, let's see, where was that? You have learned to create. That was the first one we're going to get. And if that's found, we need to go to this one, down to the bottom. Here we are, line 513. More string indexes. This one's of 9. Potion of. So this I already have a good feeling, and then the dot. So basically, if I remember what that was looking like, where do I have it open? Potion. So right here. So now it's looking for up to this point right here, and then it's looking for the dot to get the index of that. And so I'm guessing very quickly it's trying to see, oh, what is the potion name that the dungeon master is telling me to look at, and pulling that out. And then based on that, let's see if we can figure out, there's some replacing, some splitting, and then there's a get bytes from table. Ingredients. I wonder if we went past the potion already. Well, it's doing something with the potion name, or it's getting the potion name, and it's also doing a get bytes from table. And this is where, so we haven't really talked about these tables, but we have this table of ingredients. Well, I guess we did look at this a little bit. The table of ingredients points to this up at 0, ending in 0, and then this is looking at the offset of 8. The offset of 8, if we remember, is the length of the table. So in this case, the ingredients table is a length. There's an 8-byte int here. In fact, I can just define that. Weird, no, maybe I can't. Try that again. Ada, here we go. Quad word, cute word. There it is. Not sure why it's defining that as 0. That's weird. Oh, because, okay, this whole thing is already set up as a big array, so it's not quite the right kind of array, but it is from E80 to E98 is some other kind of array. It doesn't, it's incorrectly defined. I could fix it, but for now I don't need to. I can just look at, so I'm looking at the offset. Let's Control Z to get out of whatever I just did. I'm coming here, I'm looking for offset of 8 bytes in. That's these bytes right, 8 to F. So it's all zeros except for 01, 100. So OX100. So it's passing in the length of the ingredients table, which is OX100, and then the table itself is here at 94B580. 94B580. And here is where we have, now here's the actual strings. So I have a pointer to a string from 80 to 88 or 87, and then I have the length of the string right here. So that's 4. And then I have a pointer to a string from there to there, and I have a length of the string, which is E. And I can show the string if I want to by going to 74D162, and here it is. This one is bone. You can see the other ones start to come here. Other strings that are showing up in here as well. So we're doing something with get bytes from table on this thing that happens to be, this is a very convenient thing. When it's OX100 bytes long, that basically means that there are 256 options, which is very convenient because that's, if right now I've got an idea that ingredients convert to bytes. Let's see, so then we come down here a little further. There is a send here. Let's see what these, this looks like a 7-byte long string. Data R7 priv message. That's what we saw at the front of every message. It looks like it's probably building the string. Here's the dungeon. Here's the dungeon string, 8 long. And then is this a string? It is, and it's 2f long. Data type char ox2f. That is a very weird potion. I don't trust it. Okay, so here we have some sort of there must have been some mapping where if I failure state. Now I didn't see this in my IRC data, but some kind of failure state happens here. This check, it sends here, and then the else is the rest of it. So it's good to know if I see that message. I might have messed up somewhere, but probably don't need to worry about it. See, is this a string? No, this looks like a global of some kind. Okay, here we are. Now we're down to an interesting vm.load program. So when you think about a virtual machine, you know, not the virtual machine like I run in VMware or VirtualBox, but a virtual machine being a set of opcodes and that take some action on some variable. I can start to go through, and there's actually a way I can dig in and find these, because this video is getting long and I didn't actually go into that detail when I was solving it because I found a shortcut. I'm going to kind of skip through that right now, but basically what I can take away from this right now is, and what I need from this right now is, the ingredients list, the potion name in the ingredients list is being read in, the ingredients list is converted to bytes, and then those bytes are passed into the load program here, and I can see this. And then that is basically the end here. It gets to the end of here. It does do a send. Oh, let's see. There's the priv message dungeon again. And is there, let's see, is there another string in here somewhere I should be looking at? Here's a 21, hex 21. Let's see. Data, choose data type. Char ox21. I have now learned to brew the %s. So this is, now it's building that message saying, you know, if I didn't bail out ahead up here and say, that's a very weird potion, I don't want to do it. Now I'm saying, I've learned to brew it, we're good. I send the message back right here, and I am now done with that processing. I can do the same thing looking at, let's see, where was my, so here's my check. It stares at you imposingly. Let's look at that one. This time, let's see what we're going to look for. This one's got a length of C. Encounter. So if we remember, it will, you know, the C2 comes back and says you encounter a something. C. And then down here, this is 11 in the distance. So again, remember it's trying to isolate what's the monster it said. 11 in the distance. That's cool. So again, this is all just like trying to cut out and get the variable information that the server might have been sending. We will over here and change the data on this to a B. Imposingly. So now it's looking for the end of that. That's fine. Here's another one. What do you do? So that's okay. That's looking for, we're looking for the end question that says we are to start responding. Okay. So now we have find potion by flavor. That's an interesting one. We're gonna have to come back and look at that one a little bit more closely. In fact, I wonder if we should take a look at it right now. Actually, I'm gonna go ahead and put that on my list of things I want to get to when I'm debugging, because I'm not, you know, what is potion by? It's finding a potion. It's worth looking. I guess maybe we'll take a look here and say, if I look over here in the functions, I see there's this potion module. I'm not quite sure if that's the right word, but there's wizardcult potion. And what's cool is there's find potion by dungeon, find potion by flavor. Neat. Okay, but there's also these two other potions, command potion and read file potion. So right away, I saw two potions in the IRC I looked at. The first one was an acid resistance, and the second one was water breathing, I believe. So now there's a huge table of potions, but if those, I wonder if those two potions somehow relate to read file versus command potion, because that would be a kind of useful. Okay, so the potion name is what kind of potion it is, and then I feed all these bytes into the VM, maybe to get the arguments. Okay, I've got another message here that's getting sent back. Let's see what the message says. Data type. How long is this one? 3E, a long one. I don't have this potion. I can't handle this. Can I view this any? Is there a way to view this in full? No. Okay. Oh, clearly this is the error message again. So look at the potion by flavor. If the flavor does not return something, I'm guessing maybe one of these two potions, it's going to fail here, and it's going to return. I don't know. I can't do this. And it makes that thing. It sends it, and then it returns. Otherwise, it did find the potion, and then it's going to send back. See what you look like. I have quaffed my potion. Oh, we're going to drink the potion now. So this will be a char of, how long was it? I lost it somewhere in here. 1D. I quaffed my potion and attack. Great. Basically that says, cool, I've received the potion instructions. I'm now able to continue going on. It sends that. And then it actually runs this 1B0 here, which believe, let's see, it's set to pvar 17, which is defined coming out of this potion by flavor. Again, the variables aren't quite lining up the way I would hope if I was doing this in a really detailed way, but again, I'm just trying to get an idea here. I'm guessing this is calling one of these potion functions. And where was I? So that was right here. And then I'm calling comms.castSpells. So I wonder, we should look at, we saw comms before as well. What else is in the comms functions here? Just process message and cast spells. Okay, so kind of cool. And that's, so I already have this idea that I'm processing all of the, I'm processing something to get all the instructions, and then I send back data in the spells. And so the cast spells is probably taking the output of the potion. So the potion either read a file or it executed a command, and the results of that are going to get passed to cast spells, which is presumably going to send back all those, I cast this spell for this damage, I cast this spell for this damage, which is an encoding of the information. And we do end with a send down here. I wonder if there's a final message I'm missing in here. There's not. I wonder where, let's see. Well, again, I'm not going to dwell on it, but I'm going to, there's a final send down here that would make a lot of sense for that to be the, like, oh, I'm finished with this, you know, whatever it came after all of the, I cast, let's see, I cast, so there it is. I do believe I've slain the goblin. I bet that's in there somewhere. And so right now I've got this pretty good idea of what's going on in here. And there's a couple ways I could approach this. The first way, and I think probably the intended method for solving this challenge, is to go in and actually pull the bytecodes, understand the VM, dive into that, and then I can sort of reverse what's going on and figure out, okay, what are the spells cast in the PCAP and what do they mean? How are they the output of the VM? The alternative and the route that I went is, at this point, I'm going to write a program that allows me to impersonate the C2. And so I will have a Python script that joins the chat on my local server. And then when the malware connects to it, it's going to send back the same information that was in the PCAP. And that'll allow me to put breakpoints throughout the program and debug what it's doing and see what it's trying to do with these things. I guess at this point, we will go ahead and start to look at a Python script. We'll need this open. Let's do a little bit of cleaning of windows here, just not to get messy. We aren't using this one anymore. And we will still use our, that, and we'll open up a new one. And okay, yeah, here we can start our Python program. I'm going to be using a Python module called Pytl here. Pytl is a Python 3, so I can spell it right, a Python 3 IRC client that it's asynchronous support. It's just a really nice and really pretty easy to use. So that's what I'm going to go with here. I'll create C2.py. You can check out their website for their dummy sample programs, etc. But it's pretty easy to get set up here. So we'll do user bin python 3 import title. Again, I don't know why I keep wanting to put the D first. And then what we're going to do is define a class, and that class we'll call bot, and it's going to subclass off of title.client. And we need to define two functions here. So the first one is going to be, they're both async functions, and the first one's called onConnect. And what this is going to do is say, what am I going to do when I go ahead and connect to a server, what do I want to do? And I'm just going to use, this is where the benefit of their client comes in. I can just use self.join and give it a DUNGEON dungeon channel, and that's exactly what I want to do. I'm in. Other function I want to go ahead and do is def on message. And this is how I'm going to handle whenever a message comes in. So this one takes a few arguments. Target is the channel you're in. Source is going to be the username who sent it, and message is going to be the message itself. And so we can do a really simple, do an f string here on target equals new line, source equals, and a new line. And if you're not familiar with this f string syntax, when you do a variable name with an equals, it'll actually print the variable name and the result, which is kind of cool. Really nice for simple debugging. So I can do something simple like this. And then all I have to do is create an instance of my bot. So bot, and it takes the username you want to use. In fact, I'll go ahead and I'm gonna go ahead and make my bot dungeon master, and I'll go back to just being oxdf. And then I can come over here and now make the bot the dungeon master. Very cool. And then do bot.run, and I need to give it the host to connect to. So that's localhost. And I'm going to go ahead and set TLS equals false because we're not using TLS here. And I think that is all we need. Let's go ahead and see where I made a typo. Python 3 C2.py. And if this works, what we will see is the dungeon master will now join the channel here. And here it is, dungeon master has joined. And if I say like, hello DM, cool, we see the target is the dungeon channel, the source is from oxdf, and the message is hello DM. We can even go a step further and run the induct code here. And it takes a second, but we should see a randomly named character join the channel and print the hello, my name is, let's see, so here comes Ostrich. Yep, so here's the channel, hello, I'm a level 5 sorcerer, blah, 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 blah. Sweet, let's go ahead and kill that, come up here. Clearly we don't just want to log messages that are being sent, we want to reply. So let's go ahead and delete this. And what we really want to do here is, first thing we need to check, and you should always check this on this kind of thing, is I don't want to reply to my own messages because my bot's gonna be sending messages. I don't want to process those. So in the docs, they do if source is not equal to, and then they put everything in there. For me, it's just easier to do if source is equal to self.nick. I think it's just nick. No, I think it's nickname. If the source is me, go ahead and return and don't do anything else. Now the rest of the way through, I can assume it's not somebody else sending. I could also just do if the source is well, no, I couldn't. I was gonna say dungeon master, that's me. And I don't know the name of the client coming in because it's random. So okay, now from here, what do I want to do? I've got the IRC over here in this window. I'm gonna go ahead and name that to IRC text, and let's do a search for hello I am. There it is. So that's the message we're gonna look for. So we'll grab hello I am, and we'll do if message dot starts with hello I am. We are going to reply. What do we reply here? So and so, what is your quest? So we are going to do, again, we can take advantage of the self.message, and then we just need to send it back to the same target. And then the message is going to be format string, paste that in. Now, it's not always going to be ISIL, though, so we need to go ahead and change this to source. And that should work. So let's go ahead and close that out. We will join the dungeon master here, and we can go ahead and then also join the client or the malware or the bot. So dungeon master's in, and now we just wait a second for, okay, so Izzerin has joined. So let's see if Izzerin's going to say, hello, I'm Izzerin. It does. And does the dungeon master reply? It did not. Started with hello, I am. Interesting. So we need to debug this clearly. Oh, we have an error. Your message was never awaited. Oh, cool. Okay, so that's again because this is dealing with async stuff. I got to put await in front of this. So let's try that again. Close this off. Right here. Close this. We can see both of them, Dungeon Master and Izarin, have left. We'll put them both back in. And let's see where it goes from here. So Dungeon Master has joined. We should see a new character come in here. Looks like Ickylis has joined. Oh, and look, I'm replying, and then he's replying there. So this is cool. We're now interacting. So what do we want to do next? Let's kill this, kill this. What do we do next? So next we're going to say welcome to the party. Let's see. After we should say we say what is your quest? They want to retrieve the big pterodactyl fossil. So let's just do a search for my quest is to retrieve elif message dot starts with my quest is to retrieve, and what do we say? We say welcome to the party, and then we immediately start in with the potion. And now what I'm going to do really is I'm going to send this entire potion exactly as it's sent in the PCAP, because that's what I want to simulate happening. So let's see, target. I think it had the name in here, right? It did. Welcome to the party. So let's go back here. So it should be source, comma, welcome to the party. And then immediately after that, we're going to await self.message target. And now this time I want to send the potion stuff. And I don't really want to hard code this potion into this potion is long. So let's go ahead and get it into a text file. So I'm going to come down here into the same thing. So I'm going to do the easiest way to do this. We're going to do a grep for Dungeon Master to get just the Dungeon Master lines in IRC.text. We're going to call this, we're going to send it to potion acid resistance. Then that, and we're going to start to, oh, actually, hold on. We don't want that. That's not quite what I want. Let's go back and look at this again. So if we put this into less, just because it's easier to see, there's all sorts of stuff here. In fact, some stuff I don't want. We might want to add the exclamation point user at 127, 127, or just grep on priv. Let's just grep on priv message just to get rid of. So we'll do another grep priv message into less. Okay, this is looking better. So now we got just the messages sent from Dungeon Master, which is what we want. Now, so let's send that to potion acid resistance. We'll vim that up because we don't. Oh no, so it's still not quite what we want. Back in less. I don't want all the garbage beforehand, but it looks like if I split on this colon, I can get the actual message. So I'll do a cut -d there, -f2, send it to less and see what it looks like. Looks like we're not. Looks like we get the wrong field. Let's try 3. There we go. And there is just the messages, which is what I'm looking for. Okay, cool. So let's get rid of that. Now that is what we're going to finally send to potion. Oops, not that, but to potion of acid resistance. Now when we open that, let's zoom in. So I don't want this first line. I don't want the second line. I don't want the name because I need to be able to change that, but I want the rest of this. So let's see, let's keep going down here till we get through. Okay, so here you've entered the dungeon, so we don't want that. Let's get rid of that. Go all the way to the bottom here and delete. So now what I have in here, what I have in this file is just the message that sends the potion of acid resistance. Let's get that file name. and we will come here and we will just do a simple with open that read as f POAR equals f.read. Now I wonder if I need to do anything with the new lines or if it's okay the way it is. I'm going to go ahead and just give it a try the way it is. Let's see. So now I want to do, the message is going to be source, comma, oh no, the comma was in there. So I just needed to do potion of acid resistance, send that in, and let's see if A, if this sends, and B, if the malware responds to it. I think that looks good. Kind of not expecting this to work on the first try, but we'll see. So Dungeon Master is joining, and okay, in comes Denorium. What is your quest? He replies, and receive queue exceeded. Dungeon Master has quit. The receive queue has exceeded. So I did respond with the welcome to the party with the receive queue. So now we're going to be into the part where we need to start tweaking our IRC settings. Because this is, I can actually look at this message here. This is an issue that I'm seeing with my server. Is basically saying, this is too much message coming from this one user. Please stop. And so I'm going to go ahead and try to fix that in the server. Let's go ahead and see what's so that is, I'm going to need to be root to mess with this. Sudo vim etc inspire, IRC, and then it's in inspircd.conf. And we saw the receive queue was what I exceeded, which is set currently to 8,000. So we're just going to put some really big numbers in front of that. And then we're going to do sudo service inspired restart. And when I do that over here, I get disconnected. We're seeing now if I can reconnect, it should take just a second. But I do want to wait for that to come back up before I try to run my other stuff where I might get weird behaviors. So let's see. Okay, now talking to Dungeon, so it looks like I'm good there. Let's go back up here. We're still happy with that. So let's run our C2 again and run our malware again. We should see, again, Dungeon Master should join, and then a name should join, and we'll see if we can get it out the way we want here. It joins. What is your quest? Welcome to the party. And here comes the stuff. And we'll know we're successful if at the end we see the malware reply with whatever it says. It says something like, I've learned how to brew the potion of acid resistance. That'll sound like success to us. So this should only be a few more. Let's go ahead and let this run through. We'd have an interesting end line, new line at the end here, and it didn't work. So I'm going to need to do a little bit of troubleshooting on that. Let's go back to here to our, close this off. I'm going to guess it has something to do with new lines. So what I'm going to try next is my potion of acid resistance. And I'm going to do a search for, I always forget how to do this in Vim. It's something like, let's see if we can pull this off. I'll pull this. Search for new lines, and then I want to put -r globally. Does that work? No. Could do this really silly way by just putting end and deleting a lot. And there's one other tip we're going to go for to try to make this go faster. And that is, you noticed how it was only allowing one message to come per second. And so once we're done with trying this new line thing, okay, so we have this, let's get rid of the new line. We should have a word count as just one, okay. The other thing I want to do to try to go faster is we're going to go back into here. And this is a setting I found way too late in the process. I lost a lot of time for not finding this. But if we go ahead and increase the threshold, and then do our restart of the service, we have to wait just a second here while the service is down, coming back up. Once my hex chat joins, I'll be confident that worked as well. But what this is going to do is instead of sending one per second, it's going to allow 1,000 messages per second, which means that I won't have to wait, you know, if this is 20 messages, I won't have to wait 20 seconds for it to come back up, which is nice. So let's see, we're back here. We're going to try to run the C2 again. C2 is going to join, and we're going to go ahead and run induct. So there's our dungeon master joining. Let's see, our user comes in and it works. I'm wondering, it still is not, still not coming through. Oh, I bet you this is the failure right here. It's not an issue with the ingredients, but it's an issue with the source here is not actually, it's, you know, I bet you it's not registering the welcome to the party because I forgot to make this an F string. And it's an easy mistake to make. So let's try that again. Close you, run you, run you. They both quit. Here comes the dungeon master coming back in. I've now learned to brew the potion of acid resistance. I'm a little bit annoyed there's a new line on the end here, but I'm gonna let this go because it seems like it's working fine. So that's cool. Now we need to add the next step. So we're just gonna keep coming up here and working through elif message.starts with. Come back here, we can grab it right out of here. I've now learned to brew. I don't really need that W, but we put it there anyway. Now if the message starts with that, what do we send next? Go back to our original here. I have now, so now we're going to enter graphs infernal disco. Interesting, it's got 2 dots on the end there. We're gonna make sure we get that. This one's short enough that I can just put the whole thing in there. Await self.message target source, and then paste that in. And we should be good there, and we should expect to see, we can go ahead and add a few steps here actually. So now we're gonna say you enter that stuff. It's going to reply, I draw my sword and walk forward. So we'll go ahead and add the next elif message.starts with, put that in, and then we reply, you enter the dungeon, oh, we did that one. Look at my, you encounter Goblin in the distance, it stares at you imposingly. What do? Wait. Self.message target source. You encounter the Goblin. What do? Okay, that looks good there. Now this is where it's going to start responding with, I quaff my potion and attack. I cast. And then we send another potion. So that's really the end of it. So this would be a good place to make sure we're up and running as we expect. Let's kill that. What have I got in here? Oh, somehow Vim added a new line to me. Get rid of that. All right, it's joining. Now, if this goes as expected, I should see all the way through the malware doing its thing and slaying. Okay, it has, I quaffed my potion and attack, and it has slain the goblin. It didn't do anything in the middle, and that's interesting. We'll exit status 2. We don't know what's happening. So that's clearly the next thing we want to investigate. This is actually where it's going to be kind of cool. One thing we can do is put strace around this. We can go in and debug, but let's first try that. I don't know why I put parentheses around it. So waiting for a new one to join the channel. Okay, I do believe I've slain the goblin. Let's look through here and see if there's anything we can find that would be useful to know. If not, we'll go ahead and debug. I actually didn't do this originally, but it was an idea I thought of later. So we see get socket names. Here's, okay, so we run induct. Okay, I'm not seeing anything super useful in here. I thought I might see it try to do a file read because that's what we, or a command execution. Well, we can check here. Let's see. Is there a, let's say, was there system? No. Is there an exec? The original exec. These are all not that interesting. Socket, 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 and we're back at the beginning. So, okay, let's not worry about strace. Let's go back into the binary where we were looking in the code browser, and take a look there. We've got, where were we here? So we're processing the DMM message. When we got to the message with the, let's see, oh, is the let's see, where were we when we managed to off my potion and attack? Here we go. This is good. So let's figure out what's happening before that. Don't have that potion. So find potion by flavor. This seems like a good place to look. The find potion by flavor, and then once we have that, somewhere below here earlier we found where it actually called that. Let's see. I think right here. So let's get that address as well. So this address is going to be 65.2D59. And so we're just going to do GDB induct. I'm going to break on that address right there. And so that breakpoint 1 is this unknown call, and we're also going to break on this get potion by flavor, which is going to be at 2B87. 87. Now we will run. Let's see what we hit. Okay, sorry for the kind of disjointedness here. Actually, just as I was starting that previous step, the power at my house blinked and my computer shut off. So I didn't want to recut that whole video up to this point, so I'm going to just keep going from here. I've gotten things back into the current state. I've got Ghidra open. I've got myself joined into Hex chat here. And I have gone ahead and set, let's see, so I've started the C2 server here that we had running before, and I've set the same 2 breakpoints on the find potion by flavor and the calling of the unknown function. So I've run up to the point now where I have hit find potion by flavor. What's interesting here is it's passing in. It's not exactly clear to me what's getting passed in here, but you know, it's getting the fact there's a goblin in the distance there. The beast smells quite foul. What do you do? It's not clear to me exactly what's going into this as inputs. I was expecting to see something like positive acid resistance, but maybe that doesn't matter. Maybe it's more either the goblin name, because you know we saw the other monster that comes up is the wyvern, or maybe it's something to do with the smell. Anyway, it doesn't totally matter to me here. I'm going to step over this and see. It does return potion of acid resistance as a string here. So that's the potion I wanted for sure. And there's not much else I'm getting here, actually. I'm going to go ahead and continue to get to the next breakpoint and see if that one is any more useful. And let's see, I'm at a move instruction. That's not, I was expecting a call instruction. 652D59. 652D5. Just, it looks like I'm 5 or 8 instructions too early. Cool, we'll just step ahead through those. There's my call RCX. Okay, call RCX, and it's a little, I'm trying to make the text, well, let's see. We can see right away, what are we calling RCX is the command potion. And, you know, again, I'm not sure whether RBX is the actual argument or it's same also down here on the stack 8N, but LS Mage's Tower. And earlier, when I ran this, just running it, I saw that it said, you know, I attack, and then it said I've slain them, and it didn't even show any damage or anything. And I wonder if that's because if I do an LS on Mage's Tower, it's going to return nothing, and so maybe nothing comes back. So to test this, what we're going to do is we're going to do a sudo make dir Mage's Tower _tower. Let's go ahead and change mod 777 this to make it very readable. Of course, I need to do that as sudo. And then just for while we're doing this, I'm going to go ahead and let's see, echo Please subscribe to my YouTube channel. Into /mages tower hello.text. Cool. So now we've even got something defined there. We'll go back to our debugging, and I'm going to go ahead, just having some idea that it's running the command potion and knowing what it's running, I'm just going to go ahead and let it run and see what happens. And go back to hex chat, and you've learned to, oh, it looks like what happened is it actually timed out. By the way, I did figure out how to make this text during my reboot. I figured out how to make the text a little bigger here, so hopefully that's more readable for you. Let's go ahead, and now that we've put that there, let's quit GDB and just run induct the normal way. We'll look for it to join here, and now I'm expecting to see a little bit more coming back, not just, yeah. So look, this is cool, so we can even start to say, it's got 1, 2, 3 lines here with full information, and then a partial line where it casts a spell, but it doesn't return anything. This is interesting. We can start to take a peek at this. What happens if I do ls/mages tower, which is the command it ran, and I put that into a word count. It has 10 characters coming back. If I have 3 lines, I can really quick. I can start to guess at this. But I've got 3 lines and a partial line. So it would make a lot of sense if this was 3 bytes per line, and then maybe 1 byte on this line. I could test this again. Let's see. Touch mages tower, another file, another file. And let's see. So if we do that word count now, we expect 23 characters. If our theory is correct, that should be 7 lines and a partial. So let's go back here. And we'll kill this again. We'll run induct. We'll go to hex chat, and we'll see what the new one does. And this is the kind of dynamic reverse engineering we can do to figure out, we don't have to go understand the code if we can understand what's going on here. So let's see, 1, 2, 3, 4, 5, 6, 7, and then that gives us 21, and we're trying to get to 23. And this is interesting because you notice all these damages have a number, a D, and a number, but this one just has a single number. So I can right away have a theory that there's 3 bytes per line. One is this spell name, one is the first number, and one is the second number, and that's why I'm getting 23 bytes here. So this is very cool. I'm very happy with this. I'm going to take a second here and think back. Okay, so now that we're making some progress here and we're understanding what's going on, what is my actual goal? I don't think I really care about, I'm trying to get this flag, right? I probably don't care about the results of the LS. I'm guessing that I care if there are 2 potions, one's to execute commands and the other one's to read files. And if I look at the IRC here, the first one was, okay, there's not much sent back. Let's see how many bytes did it send back. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 27, 28 bytes. It's almost certainly not the flag. It's certainly going to be a file name in Mage's Tower. And then I send another, the PCAP shows another potion being sent here. And then this one, and let's just see how many lines, like this is a lot of lines. This is clearly a file, probably reading a file. And so what I need to do here is, the flag's almost certainly in this data right here. So what I really care about now is not the first one, but the second one. And so I'm going to go back and basically change my C2 around here. I want to not send the Infernal Disco, Goblin, Potion of Acid Resistance stuff. I want to send the second one. And so I'm going to make some updates to this file here. And so let's see, how pretty do we want to make this? I guess we could set it. So what if we import what's this? No, it's a pain. Let's not worry about making this super pretty. Let's just replace what we had and fix it. So welcome to the party is going to be the same. This is where it's going to change. So we're going to fix that message, and we're going to fix that message, and we're going to fix that message. So first, we need to do the same thing we did before to get the potion of whatever the other potion was into a file. So we'll go back to the IRC window. And see, I get to remember how I did this all over again because I don't have it anymore. Cat IRC.text into a grep on my dungeon master here. Yeah, a large file. It's probably like an image file being excluded, exfilled here. Geez. Okay, this is taking longer than I expected. Go down this way. Okay, here we go. So we wanted this stuff right here. If I remember correctly, we used 2 greps last time, so we're going to grep for Dungeon Master. Then we're going to grep for priv message. And let's just throw that into less to make sure it's got what we want. Cool. Now we're going to cut -d on the colon. Oh, and the reason I got it wrong last time, there's a colon right at the start, and there's another colon, so that's why it's F3. That into less. Awesome. And now we just need to get, now we can put this into, what was the other potion called? Not that it really matters, but there it is. Potion of water breathing. So we're going to put this into potion of water breathing. I'm curious to see if we need to, I remember last time we had to go in and we went in and messed with those new lines, but that actually, I'm not sure if that was the problem or not. So curious to see if that changes things this time. Okay, we don't need this. Counter Goblin. Okay, get rid of all that. And now we go to, let's see if we can find the end of this. Undead. Okay, so yeah, here's the new. There you go. That should be my full potion right there. Back to my main program. We can do a 3YY to yank and then do a P here. Delete that, delete that, delete that. And so we're going to do the potion of water breathing. It should be nice and complete here. This should be WB. And then we should return source post of water breathing. Now, we could do some experiments here. Remember earlier we were trying to figure out what actually selected which potion got used, and we could try sending back, like, messing with just one piece at a time if we wanted to, like, see exactly how that was happening. And we might need that later. Well, we're not going to need that later, but if we did come to need that, that could always be here too. So now I've learned to brew. See, we need the, you have, paste that again, and this time, you delete to quote. Sweet. Okay, so let's go get the next line out of the IRC. You have, what is it? You have entered? Oh, it's you enter. You enter Dungeon of the Sunken Crypt. That's the one I want. And this one actually takes 2 lines, but it's not, still not so long, so I can just copy the whole thing, come in here, paste that in there, and we just need to get rid of common and bad. That looks pretty good. And then the last one is we need the you encounter line. So again, we yank paste this to get it where we want it, and we will DT double quote to delete to the double quote. And it's right. You encounter the Wyvern. It stares at you. What do you do? That's our text. Excuse me. This is interesting because instead of smelling foul, it's sitting in the water, waiting for me to approach. Cool. Don't really know what that means, but let's do the exact same thing we just did before. So now we got a new C2. We'll write this. We will call. We'll do GDB induct. Really put a Q in there to keep that quiet. And then we want. Let's see if is that breakpoint still there? Yes, let's put the breakpoint there at where it's going to run the command, and we will run and see what happens. Dungeon Master's there, that's good. And we'll see any second now. Okay, here's Odorin, it's breaking. Let's see what we got. The potion of water breathing. We're at a, I really should fix that breakpoint. Here's my RCX, which is calling the read file potion, and it's calling Mage's Tower cool wizard meme.png. And so, boom, now here we are. We have found exactly the thing it's trying to read. So the file being exported as exfilled as it attacks the Wyvern is the contents of cool wizard meme.png. I feel incredibly confident at this point that that's where I'm going to find my flag. I'm going to go ahead and bail out of GDP at this point because I don't think I can. I want to do some more dynamic analysis looking at what I got here. So I know I have this mage's, where's my path here? Cool wizard meme.png. And so I'm going to see what happens if I put some test data in there. So if I just do an echo of a bunch of A's into that path, and now if I run induct, let's see what comes back. Here I am talking to the dungeon. Hopefully the dungeon master is still working. Okay, cool. So I got data back, and it's so the easiest answer would have been if I noticed I put in a bunch of A's and I got the same spell over and over again, and I got the same value back. And clearly that's not happening. But I can start to look through this and I can start to notice a pattern. So for example, greater restoration 245, 247, 1, 2, 3, 4, 5, 6, 7, 8. And then on the 9th line, it's the same thing. Locate creature 134, 160 matches up here. Hold person, blah, blah, blah. And if I come down here, here's greater restoration 245, 247 again. So what I am seeing here is what looks like a 24, it's some sort of stream cipher, but that it's, it's a 24 byte key. Or whether that's a straight XOR or however it's happening, the pattern match of an input of an A looks like a 24 byte key. And that's useful. I should poke at that. So the next question would be, okay, so if I change one character in here, let's change the third character to a B, and I run it again, what changes? And so let's come back over here. Aras has quit. Let's wait for our new person to show up here and do some fighting. So my greater restoration lines were here. Greater restoration here, 245, 247 is what I had before. 245, 247 is what I had before, but the third character right here is different. So it looks like, again, if I change a single character, the only thing that changes is that at that place. So the encryption of individual bytes is independent of all the other bytes around it, which is super useful for me because it means I can start to come up with a Rosetta. And the cool thing I want to try next is I know, let's close this out. I know that PNG starts with, I can't remember what the first byte is, but the next 3 bytes are PNG. So I'm going to put that in. Oops, I don't know why I put that W there. Let's just try that again. I was treating it like Vim. That looks like what I was looking for here. And now I'm going to run induct again. And what I'm hoping for here is, I have a good feeling that the actual bytes on in the flag, the first 3 were PNG. I don't know what the first thing was. So what I want to do now is compare this to what I got here. So I don't know about Stinking Cloud. Clearly my A is not right. But then I have 116, 157 dominate person. 116, 167 dominate person. So PNG header is actually longer. It's like 8 bytes long, so I could get the whole header in there. But what I'm showing here is I'm pretty sure I can, if I know what the that I can map 116 in the second position to a P, and I can map 157 in the third position to an N, and I can map dominate person in the fourth position to a G. And so what this means is, if it truly rotates every 24, that if I send 24 A's, what I will get back will be the answer for each position as to what each thing in the position. So I know that at position 0, 1, 2, 3, 4, 5, 6, hold person is an A. every time I see position in anything that, position 6, position 30, position 54, I'm adding 24 each time, it's always going to be a 6. It's always going to be a hold person for an A there. So what I can do is I can create this file that's going to be a giant block of text, of every byte. And so it's going to be 24 bytes of nulls, 24 bytes of ones, 24 bytes of twos, 24 bytes, all the way up to 255. And then I can decrypt that, or then I can send that in and get back what would basically be kind of like a Rosetta Stone. It'll be my guide for, okay, for any given position, for any given input byte, here's what the output looks like. And then I can take that, apply it to the function, and get back the file. So that's what I'm going to try to do. So the first thing I'm going to need to do is go ahead and create that file. So see, this will work. Let's go ahead and drop into Python. And what I need here is a file that has 24 zeros, 24 ones, 24 twos, etc. And so I'm a big fan of list comprehensions here. So X for X in range 256, because I need it all 256, and I can see that that produces that. But I actually want 24 of each. So all I have to do here is do for Y, or I can even do underscore in range 24. And I'll start with 4 just to show. So it does 4 zeros, 4 ones, 4 twos, etc. That's exactly what I'm looking for. The other thing I can do is put bytes in front of this and wrap it. And so that'll produce a nice byte string here that I can write to a file. So it's starting to look good. I just need to change this to 24. I will save this into a variable called B. And then I can simply, with open slash mages tower slash, let's see, was it cool wizard main.png. We're going to write binary as f.write b. 6,144 bytes. That looks good. We can test it. We can xxd mages tower cool wizards meme less, and it's exactly what I was hoping for. So 24 zeros, 24 or nulls, 24 ones, all the way through, all the way to the end where I get 24 FFs. So that's a good looking file. Now when I send that in and encrypt it, basically I will be able to look at any position 0 through 23 and the value that came out, so what I have in the PCAP, and I'll be able to trace that back to what the value that went in must have been. So very neat. Okay, coming back to what I have here, I don't need induct running, I don't need the server running. I'm gonna have to make some changes now to my C2 server. And what I want to do basically is capture the ICAST blank function things. Interesting that something just joined. I wonder if I have a kill induct. Okay. I want to capture these ICAST messages, and I want to start saving off the results into some structure. Now the first problem I have to address is these onMessages things are called uniquely each time. So I can't just keep a variable in the onMessage function. I'm going to have to put something at the class level. And so to do that, I'm going to go ahead and put it at the, define a init function. Currently, I've not defined one, so it's just using the one from Python client. So if I do a def underscore init, and that takes in self and a name, the first thing I'm going to want to do is go ahead and call the init function from the Python client because it's important. It does a lot of stuff. I don't even know what it is, but I want to make sure that that gets set up the way it was called before. But now I can start to define the things that I want to store and save between calls. So first thing I can do is do self.rosetta and make it a dictionary. And basically what I'm going to do is I'm going to have a dictionary where if I put in Rosetta and then a number that's 0 to 23, so say like 10, and then I'm going to put in what is the value at 10. In fact, I can come over here and do it right now. Let's say if I want to put in greater restoration at 0, so I can copy. My goal is going to be to have a Rosetta that I put in that, and then that, and that the result that came back was the plain text byte that led to that encrypted result. So I can also do, Rosetta sub1 of, it would be a string 116, and get the result of what the second byte is, and it's going to be a P. And so that's what I'm trying to build. Oops, that's not what I'm trying to click. Let's see. So we'll get rid of that. That's not what we needed here. So what I'm going to need is I'm going to need Rosetta to be a dictionary with 24 entries for the positions 0 through 23 that I'm running into. So I'm just going to do a for I in range 24 self.rosetta equals another dictionary. And I could also have used like a default dict here, but this just seemed cleaner than going to find that. I'm also going to need to track, because I'm tracking between messages, I'm going to need to track where I am in that cycle. So I'm going to do a self.I equals 0. And we'll save that just so that we can use that as a tracker as we go through. Okay, now I'll come down here and I need to add a new else if message.starts with, and it's going to be starting with ICAST. Paste that in. And what are we going to do? So, it'd be helpful if I close the parentheses. So in this case, what I'm going to do, the first thing I need to do is get the 3 data values. So it's the spell name, greater restoration, dominate person, dream, contact, other plane, and it's the 2 values, number, deed, number. I'm fortunate because I know from my file is going to always be a divisible by 3 number of bytes. So I'm always going to have all 3 items on my lines. So I don't have to worry about handling what if there's only a spell name or a spell name in 1 value. So I need to isolate those 3. So I'll start with what does that spell look like? Because I can't just split on spaces here because there's different number of spaces in each spell name. So, but what I do know is that it's always going to be, let's see, how long is I cast space? I, 2, 3, 4, 5, 6, 7. So it's always going to be 7 spaces in. And then I always want to stop when I get to space on the. So I can actually just do message.index space on the, and that right there will give me the spell name. So I will go ahead and save this. Let's pick a variable like a v0. And then let's save. So v1, and v2 are going to be the number values. I can get now for those. If I look here, those are always the second to last word, regardless of the length. So here I can split. I can do message.split on space, and then I can just get -2, which will give me that number d number. Now I can split that again, this time on d, and now I've got the 2 numbers, and that'll be v1 and v2. So I've extracted that from the message. I'm starting on the first line with I equals 0. So now I can start to build out my Rosetta. So I can do self.Rosetta equals, self.Rosetta, in this case, of I mod, it's not I, self.I mod 24. Then the next one is going to be a v0. That's what I'm going to want. That's the key I want to put in the future. And that's going to equal. And now, if you remember, the first 24 bytes I see are all going to be 0. The next 24 are going to be 1. The next 24 are going to be 2. So mathematically, if I take I and divide it by 24, throwing away any remainders, that's going to be the value I want to put there. I can do self.Rosetta. In this case, self.I plus 1 mod 24. And the parentheses there are important because otherwise Python will do I mod 24, which is, or 1 mod 24, which is just 1, and then it'll add to that, and I lose the mod 24 effectively. Then a v1, and this is equal to, technically it's going to be I plus 1 mod 24, because of the way that I'm going to add 3 to it every time. It's actually, I could just put I as well, but sure, we'll make it look nice that way. It might be more understandable. And this will be self.I plus 2. And again, because I'm setting 3 here because each line sets 3 bytes in the Rosetta. Mod 24 of v2 is going to equal, and again, I don't need the plus 2, but it might be more understandable there. And then I just want to do self.I plus equals 3 because now I need to move up my count as to where I'm going. And that should be the end of that function. The last thing I need to deal with is what happens at the very end. So otherwise, if I do this, and that's great, but it never gives me the results, that's not very useful. So I need to capture, I do believe I have slain. So ls message starts with, I do believe I have slain. And then all I'm going to do here is I'm going to write Rosetta to a file. So with open rosetta.json, write as f. In fact, this is a good place to use the JSON library. So I'll go ahead and bring that in. Because now I can just use json.dump self.rosetta, comma f. The odds that I made no typos in there seems very low, but let's go ahead and give it a try. So we will start up the C2. Should see it join in just a second, and then we'll just have go ahead and run induct and see what happens here. Okay. Interesting. So it's getting through a bunch of stuff, but now it's stopping to send 1 per second. And that is slower than I'm going to want to deal with. Let's kill this. Oh, and I got an error here. I is not defined. I is not defined. Oh, of course. I is not defined. Let's go ahead and fix that as well. It should be self.i, self.i, and self.i. Okay, before we do that, let's go sudo vim etc InspIRCd IRCd.conf and come down here. I'm guessing we got 1,000 messages in and the threshold got hit. So a simple way to check that would be to change this to 3,000. If you remember, we're expecting 200. Let's see, we're expecting Python 256 times 24 is 6124, but then we're going to divide that by 3 because we send 3 bytes per line. So we're expecting 2,048 messages. So by that logic, we set this to 3,000. Sudo service InspIRCd restart. Okay, now we'll come back here, and once this service comes back up, we'll give it another try. I think it hit 1,000 and then was caching after that. So if we push it up to 3,000 on the threshold, we should be able to just plow right through. All right, we're connected and talking to Dungeon. We should see Dungeon Master join, and then shortly after, potentially everything just dump right through. I do believe I've slain. Okay, so let's see. Ooh, we have a key error here. Let's see. That's not a good sign. Key error 0. Oh, okay. I remember how I was looping through up here and setting Rosetta to, I was setting Rosetta itself to a dictionary. What I meant to be doing was setting Rosetta sub I to a dictionary. That makes a difference. So let's try that again. And run induct again. There's our new Dungeon Master. And any second now, we should see a new name come in all the way through slain. No errors in the C2. Let's kill the induct. And do we have a rosetta.json? We do. It's not small. Let's take a look. Zoom in on this. Cat rosetta.json. This is the trick. I always like to view JSON. Here, I'll show you. If I just less rosetta.json, it's a utter mess to read. But if I cat rosetta.json into jq dot and then into less, now I've got it pretty, and you can see, so I start with the position and then I look at what came in. So, if position 1, it was alter self, that means the original plain text byte was 2 or 02. And I get that all the way through 255, and then I get the next position all the way through. So I've got this Rosetta here that looks exactly like I want it to. That's pretty cool. Now the last thing I need to do is just get the original text from the PCAP and figure out how to decode that back to plain text. So let's go to 1 again. I'm going to name this to IRC. So what we really want is to get on the Wyvern, because that's the thing we care about. So let's come down here and do a grep on the Wyvern on irc.text into less. Let's see what that looks like. Awesome. We're going to do the same thing we did before and split on the colon to get rid of the priv mesh stuff. So cut -d, F2, I believe, looked like it was it. And that is looking pretty good. Okay. Let's go ahead and save this as Wyvern. Now I just need to jump back into Python to take the Wyvern file and the Rosetta and put them together into a decoder. So decode Wyvern.py, user bin env python 3, import JSON, and then we'll start by getting the Rosetta file. JSON. We used json.dump to exfil it, so here we'll just use the opposite, which is json.load of f. Oh, we need the f as f. And now we need to get the Wyvern file. So with open Wyvern read as f. f.read lines, and we'll set that to lines equals that. So now I'm going to do a loop over that. So I'm going to do for line in lines thing. And what I'm actually going to do is I'm going to add the enumerate function. And what that's going to do is it's going to give me not only the line, but the index for each line. So it'll look like that. And I can even just put a PDB statement in here so I can break and see how this is working. So if I do Python 3 decode wyvern.py, I can look at what line is there. That looks pretty good. So if I want to think about how am I going to get, I need the spell name and the 2 damages. It's going to be very similar to what I did before. So 7 spaces in, line.index of on the, and there we go. So very similar to before, I'm going to do line 7. I guess I can just copy this from here. Paste that in. I need to get the v1 and v2 the same way as before. I can do that very similarly. So that's going to be line.split on the space. Get the second to last item, which is what has the damage. Put that on D. And now I've got those 3 items. So now I should be able to take the line. I've got the 3 items. I should be able to put them into the Rosetta and get back bytes. Let's go up here at the top and start up an array to save our bytes in. And so what we're going to do here, we have, we're going to take, first thing we need to do is get Rosetta. And now this, we need to know what space we're in. Now our spaces go 0 to 24. Our lines are actually going to go, we're going to rotate every 8. So for the first byte, which is going to be, the v0 byte, the position in the file is going to be the line number times 3, mod 24. So I'm going to do 3 times I, oops, 3 times I, mod 24. This will put some space in there, make it look nice. And that's going to be the position. And now the value, the encrypted value, is v0. Now that's going to be the value that we want to add. I always forget how to do this. Let's see. If I do want to do res.append 24, does that work? Res equals, does that work? What does res look like? If I now do res.append 24, that's good. That's what I want. So I want to do res.append Rosetta, that value. The second byte, I'm going to do another res.append. It's going to be Rosetta. Now in this case, it's going to be 3i plus 1. Because we're line number times 3 times I plus 1. Again, mod 24. And now we're going to use v1 as the value we're trying to get. And we're going to append that. And we're going to yank paste. This is going to be 3i plus 2. And this is going to be v2. So now for each line, we're appending 3 bytes to res. That looks good enough that I'm tempted to just let it go. Let's see what res looks like when we're done. Quit here. Key error 0. That's interesting. Key error 0. It doesn't like 0. Come back up here. I've got a little macro to just add my favorite debugging line in. Run again. So let's see. v0. Okay. It doesn't like 0. So what is Rosetta sub 0? It's not in there. Rosetta.keys. They're treated as strings. Okay, So I just need to convert this integer to a string. Wrap that, and put string in front of these two. Okay. Give that a in fact, I'm going to be so confident as to remove my debugging thing and see if this works. It seems to have worked. Let's see, what's len of res? Long. Let's see, len of lines times 3. Yeah, looks like I got a byte per line. Res, let's get the first 100. I want to say it looks kind of like it's PNG. Okay, so that's good enough. Let's quit this. I think we're there. Let's get rid of this straight statement and try writing this out. So if now we're going to do with open cool wizard meme.png. We're going to do that as a write binary, as f, and then we're just going to do f.write, and we're going to do bytes res, like that, and write that, come down here and run it, and let's see if we have a cool wizard meme. We have a cool wizard meme. It's a PNG. We will open it and see, moment of truth. We got an image and we got a flag. There we go. So again, I said at the beginning, I don't think this is necessarily the intended way to solve it. I could have dove a lot deeper into exactly what was going on in the file, but I thought this was kind of a neat approach to show how, without having to understand exactly what's happening, but more looking at the function calls and what's going on, and then interacting and debugging and writing a little bit of code on my side, I was able to just completely reproduce and get the flag. So thank you so much for listening. This was by far the longest video I've ever recorded. I've got a whole lot more appreciation for guys like IPsec and John Hammond who do this regularly because it's hard. Let me know if you like this, or if you want me to stick to shorter videos or just stick to writing. Either way, feedback is useful. Subscribe to me here if you do like getting these, and I will talk to you next time. Thanks for sticking with me.